Hi there. Good morning, good afternoon, and good evening, depending on when you are watching this. This lecture series here, we are looking at something that is very, very important in programming. And the whole idea of this concept of a function, right? It's called a function, is being able to group lines of code together, right, and give it a name. And let me give you an example. For example, right, when you during the day you say you're going to have lunch. I'm having lunch, right? I'm having lunch is like 5 words or something like that, right? I'm having lunch, but there are several things physically that you do, right? When having lunch, you pick up your tray, you go to the you go to the cafeteria, pick up your tray, stand in the line, get your plates and all that, right? Your eating utensils, and then get your food, right? And then your drinks and whatnot, and eat. So all of these different activities that you do, they all is represented by one function, one name, and it's called I'm having lunch. So likewise in programming, right? When we write, there's a reason this is called int main. There's a reason this is called main, and the reason is because that tells the compiler uh, uh, where to start executing the code. I mean, you could have thousands and thousands of lines of code, right? But the compiler needs to know where to start execution, right? I mean, when you guys, and when I say guys, I mean everybody, right? When you play a video game, right? The Xbox or whatever it is, it needs to know where to start. And in this case, main is where to start, right? So every code in the main will execute, every code, okay? Um, Sometimes, I mean, playing video games, you have a controller, right? When you press the left arrow button, whatever you got, soldier, whatever you got, will move to the left, right? That's how it is, right? Or maybe there's a jump button, it will jump. So that running to the left is only controlled by when you pressing the button, right? Or maybe the jump, right? Is same thing too. When you press the particular combination of buttons, the player will do something, right? It's only based on some instructions, just like I'm going to have lunch. It's, time has come, 12 o'clock, noon time, you want to go have lunch. That is the instruction give. So let me walk you through an example of how in C++ we write code. Let's just say we have integer x is equals to 8, right? Integer y is equals to, let's put it 5, 6. And then basically I'm going to make it really simple here. And I'm going to call it, let's go another one, right? Integer z is equals to x plus y, right? And then we simply cout, and I'm going to say here, actually, I don't want that. I want x, right? Equals z, and then after that you put your end line. Okay, go ahead and run this one and see what it gives to you. Oh, choose a language. I mean, by now you should have known it. I'm writing in C++. Okay, it's telling me the cout is not declared in the scope, and I know why, because I'm missing a very important code here using namespace std, right? So what this says is that now since I'm here, I'm not sure if you all follow, but in order for me to use cout is a code, it's a command, right? It's a code. In order for me to use that code, I need to use standard io.h, right? Cout is declared, is written in there of what needs to happen. But then you must be wondering, why is this important, right? The reason this is important is that because this is a namespace. It's almost like a section in the standard io.h, right? And that section is marked by the section is called STD, as in standard, right? So I can even get rid of, I can take this line out altogether, and I can put here STD as in standard, and with the double colon, right, and run this one, and that should SIA is not a member of STD. That is really interesting. Okay, what am I missing here? Ah, I see. Now, this standard IO, right, that is for input output. We're looking for IO stream, right? IO stream, right? That's what we're looking for. I knew something was not right. We're looking for IO stream. IO stream is a library that allows input output with the way we're using, right? The other one that we had, you can use that for other things, but let's go and run this piece. And now you see it gives you, right, it says, hey, I don't know what end line is. So end line, I'm going to put this name here as well. So if I run this line, you see it runs pretty well, okay? But the problem with this is that, everywhere I'm going to use cout, do I have to put this? Right, I don't want to do that. So what I can do, I can put that line of code and saying, well, I'm going to use this namespace, which is part of iostream.h, right? I'm going to use it. So I don't have to type this double colon thing anymore, right? It automatically knows what I'm trying to do. So running that, now it's going to do the same thing. Okay. Anyways, now you see I've been able to add two numbers, right? What if I want to add other two numbers? What do I do? Do I take this line? One way I can do that, I can take this line and I can put it here, right? And make some changes. Let's just make it easy, 18, right? 16. But since I already have int x declared, I cannot declare another int x, right? I have to take this out. I can use the same variable, but I cannot redeclare the type, right? Once the type is set to be an integer, it needs to be an integer throughout. Okay, so now if I run this one, you see it will give me an answer, right? It gives me an answer. Okay, what if I want to do another one, right? You see where I'm taking this. There's a need for me to do all of these, right? And let's just put some numbers here. It doesn't really matter. Okay, but what is it's working for me, right? I've been able to add 3 sets of numbers. The problem here is what? Is the repetition, right? I'm copying and pasting code and I'm kind of using it, right? That is the problem. There is repetition. So anything that's like I'm having lunch, it's almost repetition, right? Every day you do it, some variation, all right? Likewise here too. It's repetition. I can combine the logic into what is called a function and just call that one each time, right? So let me walk you through what I'm saying. I'm going to walk you through. Let me make some space here, right? And all right, a function has three different three important elements, right? This one, right? The very first thing you put here, a function has a return type. When you see some examples, you understand what I'm talking about. Return type means when after this function is able to do something, is it going to send anything back, right? So let me just create, and then you'll see. I'm going to say void, and here I'm going to say, I'm going to do something different. I'm going to say print hello, right? Print hello, right? So this is how a very simple function, or let's just say here, I'm having lunch. Let's just keep it that way, right? And here, I'm going to just cout getting the tray, right? And utensils. Now let's just put tray here, right? Tray, and then right, cout. I don't know. Getting food, right? Let's just keep it simple. Food, and then here, getting my drinks. Right? And then enjoying or not my lunch, right? Either I'm enjoying or I'm not enjoying my lunch. Okay, so you see, right? This set of lines that I have here, right? Several lines of code. Could be thousands of lines of code, but still a few lines of code here. And every time I want to call this function, this is called a function, right? So I'm going to put here, this is basically a function, right? And this function, let's call it, right? Let's call it in C. So I'm going to take this line out and I'm going to put it right on top. I'm going to put it right on top because I want to call this function. And I'm not worried about all the other calculation it does, but I want to see that. Right? So basically you take that name and you just call it right here. I'm having lunch, right? And as soon as when you execute this function, as soon as it comes down here, right, it will see this function call. So this is called a function call. Right? It will see that function call right away. Your execution would come down to line 26. All right, come down here. It will execute all that, and do the cout. And as soon as it hits the curly bracket, it will go back to line number 8. Right? So you see, this allows me to jump outside of the main function and go and do other things and then come back. Right? This also allows me to do this, even though I have a code here. Right? Without that line of code, these lines will never execute, right? Because reason, even though I have code here, I'm not calling it, right? I mean, you can choose not to have lunch at all, right? It's there, you just choose not to do it. Likewise, I choose, this time I choose to do it. So I'm going to put it here and I'm going to run it. And this probably will give me an error, which is a good one, right? So you see here, it says, I'm having lunch was not declared in the scope. But what does it mean? It's declared right here. I have my code right here, right? One of the things you have to remember in C++ is that it requires a function declaration, right? What that means is a weird concept. I'm not sure why it does it. Is that when the code starts executing, right? It comes down here and it says, hey, what is going on? What is this? Right? Compiler says, what is this? What it requires you to do is you can copy this function name, right? The name that I'm copying from the bottom, you got to come all the way to the main, on top of the main, and put it right there. Take out the curly bracket and put a semicolon, just like that, right? This is function declaration, right? That is function declaration. And the reason that, this works is because you will see later when you start writing C++ objects and classes that you need to have, your code is separated into 2 different files most of the time. One is called the .h, the header file, right? And that type of thing will go in there, right? And the other one is the implementation file. But I don't think that we'll be touching this for a little bit later. All right. So now, right now, running this, and it will go ahead and right there, getting the tray, getting the food, getting things, enjoying or not my lunch, right? You see, so in order for you to write a function, right, you need to give it a name. All right, give it a name, and of course you put your code in there, right? Code in there. The tricky thing about this is that, I mean, this name could be anything, right? I mean, make sure you have a proper naming convention, which means do not put a number here, do not put a 89 here, because that will not work, right? I mean, it's the same naming as you name the variable, right? Start with the something descriptive like that, and then you have a parenthesis right beside it. Oops, right? Parenthesis right beside it. And I'll in a minute I'll tell you what that is for, right? And then you have a curly bracket. Everything inside that curly bracket belongs to that function, right? It belongs to the function. Now there's a void here. I mean, what does even a void mean? So I'm going to show you in my next example. I'm going to show you what that void means, right? But basically, what that means here is that this function I'm having lunch is not sending any value back, right? Right, not sending any value. It's a very simple, straightforward function. Okay, so that's good. I'm going to move this down. Now let's go and try to see. So I don't need this anymore, right? And the thing is that if I wanted to call it again, I can do that. I can do that again each time. Even though I'm just in my main, I'm calling one function, it's going to execute all of these lines of code, right? Each time it's going to execute all of those lines of code. Okay, you want to see it? Run it, move it a little bit up, and you see all of this getting my drinks, all of this all the way here, right? I mean, that's just that's the cool thing about it, right? You know, and maybe if I want, if I don't want to do it here, I can call it right here. Still, wherever you put it, it's going to call it. Just like in the game controller, right? Game controller, when you can hit the left button or the jump button as many times as you want, but whenever you hit that button, the character will do that, right? It will jump, right? Likewise here, right? As anytime I put I'm having my lunch, it's going to have the lunch. All right, so let's go back to this one. There's a problem here. Problem is that we are duplicating, repeating code, right? I mean, it's working the way it's supposed to do, but we are basically duplicating code, which is something that we don't want to do. All right, so let's create a function here. And remember, in C++, when you create a function, there's many important things, but one of the things is that you start with a return type. Is your code going to send anything back to somebody else? In this case, it's not. So let's just put void here. Return type is the first thing, void. And I'm going to say do add, right? I'm just going to give a name here, do addition, right? Do addition, and then do addition. And then what I can do is that there's a parenthesis here, right? So this is the skeleton, right? This is the skeleton right here. In this parenthesis, there's a reason we have the parentheses, and in there you can put what is called a parameter, right? Parameter is the input that this function needs to do what it's supposed to do, right? So here I'm going to put x num1, right? Int num2, right? This function needs two numbers, right? And it's going to, the first number will sit there, the second number will sit there. Inside this function, what it's going to do is going to basically do a cout, right? And num1 plus, right? What happened to num2? Num2, oops, right? Num2 equals what? Num1 plus num2, right? And anytime I do math where I'm adding stuff on the fly, right? I always want to put a parenthesis around it. It's just a habit, because that tells me, it makes it more readable. It tells me that these values should be calculated on its own, and then the answer should be put forward, right? So you see this function here, right? Do addition, it's asking for two numbers, right? Two inputs, it's asking for two inputs, it's taking the input, it's printing it out, and then it's also adding it out, right? So let's use this, okay? Let's use this, and you watch what I'm going to do. So before I use this, what do I need to do? I need to copy this line, right? I need to copy that. I need to put it up here as a function declaration, remember? Right? Here, put with a semicolon, just like the other ones we have done, right? Now, I'm going to take this out, right? Because I don't need this anymore. I'm going to use, so 8 and 6 was the first one. So I'm going to do a do addition is taking 8 and it's taking 6. See that? So this is a function call with two parameters, right? Parameters. Sometimes those are called arguments. I mean, I'm not sure why they had different names, but actually these numbers right here is called arguments, right? So arguments, and these numbers right here on top, right? So this is a function that doesn't return anything, but requires two parameters, right? So what does it mean? Okay, so you see, this is the second kind of function that you write. The first one is I'm having lunch. It does not take any parameters, right? However, this function that we wrote, the second one, do addition, is requiring two parameters. And what happens is that regardless of what you put here is 8 and 6, right? Arguments, those values will match the position. So 8 will go right here, 6 will go right here, regardless of what this is called. You don't have to worry about what that's called, right? You can give any name. So now running this, you see, it will give me 14, right? Also, now I want to do my other one, right? Actually, we had 3 of those, didn't we? So do that right here, right here, right here. Let's just do 4 of them, right? Do the addition. I'm going to add 20 like that. I'm going to add 100, right? Run that one. See that? Now you see that I didn't have to copy and paste my code over and over again, right? I didn't have to copy and paste my code many times, right? What I did is that I created a function, I gave it a name, right? It does the same mathematics, right? It takes in 2 parameters, 2 input, proper name is parameters, right? And then I just call that function, just call it, do addition, here, take these values, right? Do addition, take these values, all right? And so forth. So that is the other way of, that is the other kind of function where it does it. Okay, let's go and change this. I'm going to change this a little bit. And, since you have seen this, I'm going to take this out. Just leave one of them there. Right? And now I'm going to write another function. And now this will have a return value, right? So function with a return value. Right? Function with a return value. And let's say what we want to do is we want to go ahead and let me think about it. I'm trying to think of a like a scenario here. I'll just make it up. Okay, so let's just say this function that I'm writing is going to function that will multiply 2 numbers, right? Right, function with a parameter, right? Parameter. What am I writing here? Return value, right? Takes in 3 parameters, right? And multiplies, right? Multiplies them, right? Multiplies the 3 numbers, right? So this function basically, now it has a return value, right? Return value, you got to put the data type. What data type is it sending back? In this case, since I'm dealing with numbers, it's going to send back a integer data type. So I'm going to say integer. I'm going to say do mult, right? Do multiply. And here is taking 3 parameters. So integer I, integer j, and integer k. 3 parameters, right? And then it takes in 3 parameters and multiplies parameter end. All right, so it takes 3 parameters, and I'm going to use another variable here, okay? It will make more sense to use it. So I'm going to say int z is equals to I times j times k, right? That's the whole goal. And then I'm going to say, okay, let's just keep it like this, right? I want to show you an error. Now, do addition is okay. I'm going to take that out, right? We don't have to. Well, yeah, you can see what's happening. I'm going to do a do multiply, takes in 3 values. So 2 times 3 is 6, right? 6 times 4 is 24. Answer should be 24. Okay, so I'm missing some things here, which is okay because I really want you to see some errors that comes up, right? First thing it's going to complain about is that there is no declaration, right? There's no declaration. So that means I need to copy this line of code and to copy all of it except the curly bracket, put it right here, put a semicolon, just like that, right? So that'll solve the first problem. All right, and then it gives me some other problem. It says, hey, in function int, there's an integer here, no return statement, there's no return statement. What that means is that whenever your function is supposed to return a value back, you need to have this code. You need to say return X, right? Because X is the one that I'm sending back, right? Return X. Now, you see, this is a common required structure for writing a function that takes parameters and that returns a value. You need to have a return data type. You need to have a return code. You need to say the last statement in this code should be returned. Or actually, you could have, somewhere else too. But almost always the last line of the code is return, right? That means do the math and send this back. All right, running it again. All right, running it again, nothing happens, right? How come nothing happens? And I'm multiplying some numbers, I'm not seeing anything, right? I'm calling this with parameters, it's doing its thing, it's returning, there's no errors. Why is it not doing anything? And the reason is, you see, this function is sending a value back, right? Am I getting that value back? I'm not, right? How do we get that value back? The way you can do that is you can say, and I'm long format here again, right? Integer z, right? And I'm going to say z is equals to there. Now, this is like a machine. I'm providing these three values as an input. It does its magic and it gives me the output, which will be sitting in z, right? And then I can do cout. And I'm just going to put z here, right? Just to make it simple for me. All right. So now you see, if I run this one, I should have 24 coming up on my screen, and it is right there, right? So now you see, so this function, right? Function call and result and return value is stored in Z, right? So in very simple format, these are the three different kinds of three different varieties of functions that you write, right? The first, no return value. That's why you have a void. There's no return statement. There's no code here that says return, right? I don't have that code. So this is, you just call it, it does it, done deal, right? Second kind is where you provide a parameter or parameters, whatever you need, 3, 4 number, how many you need, you put it there, right? It's still the very first line of code in here is void. That means this code is not going to send anything back, right? That's why I don't have a return. I don't have a code that says return num1 or whatever it is, right? I don't, because it's not going to send anything back, right? And then you have this other variety, all right? This other variety, which has all the flavor of it, right? You have the parameters, 3 parameters right here. It does the math or whatever it needs to do, and it's returning an answer back, right? And the function knows that too, because that return data type is an int, all right? And then here in the main, when I'm calling that function, I need to receive that value. I need to receive that answer, and that answer is then stored in z, right? And then I print it out, so z is just like that, right? And then also the other important thing to remember in C++ function coding is that you need to copy the function names on top, function declaration. That tells the compiler that you have this function somewhere, right? So that is how these 3 simple examples here. So I'm going to create a couple of other examples, but I think this is good for you to practice on and to get started on.